In this slide, we will be solving another example for the sign test. So the impurity level in part per million is measured in an intermediate chemical product, and the following data have been recorded. Can you claim that the median impurity level is less than 2.5 part per million? State and test the appropriate hypothesis using the sign test with alpha equal to 5%. And in part B, you want to use the normal approximation for the sign test to test H0 and H1 as provided here. Then you need to provide the p-value for this test. Okay, so let's just focus on part A, where I want to use the sign test for this example. So if you agree with me, I have a one-sided test. Why? Because the claim is telling me that the median impurity level is less than 2.5. As a result, your H1 is saying that mu is less than 2.5. So I have a one-sided test. And if you remember, we said if you have a one-sided test looking like this is a lower-sided test, the green area over here, I will reject H0 when R plus the number of positive differences is less than a threshold. Okay, let's go back and check the data that you have for this example. You have to, again, calculate the differences between individual observations and hypothesized value and see how many of those differences are positive differences. So obviously positive differences, I have 2.6 and another 2.6, and that will be all. So R plus in this example is equal to 2. I have to compare 2 with a critical threshold, and if 2 is less than that critical threshold, I will be rejecting my null hypothesis. Something that you have to pay attention and be very careful when you are using the sign test is that you have to, when you are using the table, you need to consider the number of non-zero differences. Over here in this example, you had 22 observations, but 1, 2 of these differences are actually equal to 0. So it means that you have 20 non-zero differences. 2 of those are positive and 18 of those are negative, but you have 2 differences that are 0. What is the reason I'm emphasizing on that is that when you want to find the critical value from the table, you have to have it in mind. So in this example that we are solving, I'm talking about a one-sided test with alpha equal to 5%. And n, the value of n that I need to read from this table is not 22. Instead, it should be equal to 20 because 20 is the number of non-zero differences. So the non-zero difference is 5. As a result, the critical threshold that we have will be equal to 5. The value of the positive differences was equal to 2, which is obviously less than 5. So based on the guidelines that we had, I have to reject H0. In other words, the data supports the claim that the median impurity level is less than 2.5 because 2 is less than the threshold of 5. Again, I'm emphasizing that when you are using the sign test table, the value of n that you need to read from the table is the number of non-zero differences. It means you have to count the number of positive and negative differences and ignore about the 0 differences. In part B, you were asked to solve the problem using normal estimation. We said in sign test, when your n is at least 10, you should be able to use the normal estimation. That is exactly the case over here. I have my H0 and H1 over here, and I need to just plug in the values into test statistic equation that I had. R plus number of positive differences was 2 minus 0.5 times n. Be careful when you are using normal estimation. The value of n that you have over here will be the actual value of number of observations, which was 22 over here, not 20. Okay, be careful. And in the denominator, we have 0.5 times the square root of 22. As a result, the value for your test statistic is negative 3.84. I need to find the p-value based on what you had in previous chapters. You had it in chapter 9 and 10. We know that in order to calculate the p-value is the probability that z is less than the value for your test statistic when you have a one-sided test like this. So if my p-value is calculated using this formula, I will come to the value of 0.000062, which is obviously a very small number. And since it is less than the level of alpha that you have, again, you come to the conclusion of rejecting your H-null. If you don't want to use the p-value concept, I have a one-sided test, lower-sided, and I have to compare it with negative z alpha, and alpha is equal to 5%, so this value is negative 1.645, and anything below that will be your rejection region, and the value for your test statistic is negative 3.84, which is somewhere around here, and obviously again it leads to the rejection of your H-null. So as a result, the conclusion will be the same as what you got in part A, and that will be rejection of H-null, and conclude that the median impurity level is less than 2.5.